Told you earlier, today we'll talk about Python function, and then I'll give a brief intro to the data analysis. But as I also said, I'm going to give you how raw data looks like, how the data structures that we've learned so far mimics what is seen in raw data. So I'm going to take I'm going to go through the functions briefly, and then we will move to that. So functions in Python is crucial because there are times that you like to um, reuse your code, a particular code that you've written. You would like to reuse it from time to time. So without functions, you have to write the entire code again over and over all the time. However, with functions, you don't need to write it. All that you need to do is to call the function. And we saw that when we were running code such as print. Okay. All right. So print hello world. Okay. You realize that when each time we want to print something, we don't write the code behind the print. We just call the print function, and then we put inside the print function the argument, and then Python print it. Please, do you get it? All right, so we've seen that this print over here is what we call function, and it's an example of a function. If you will recall, when we can run sum, and then we will pass on the items of the list in there. So 1, 2, 3, and then 4. When we run, we have 10. So over here, this sum is the function. So the sum without the list is called a function. So when we want to sum anything, it is not now that we are going to iterate through, right? A for loop. That's why iterate through each of the items and sum them. No. So that particular iteration is what we've put together, and we've made it a function that you can pass it on any other thing. Okay. So here we have the list, and then we have our values. When you pass these values as arguments in the function, it just calculates it for you. So that is what we are talking about, and those things are what Python calls functions. So I have some text here giving you the intuition, but I will move quickly to the syntax of Python functions, how we define a Python function. So to write a function in Python, you first need the def keyword. So the def keyword lets Python know that you are defining a function. So def, then you bring the name of the function over here, and then you bring parentheses. And if your function should take a parameter, you bring parameters over here. So parameters can be explained. Okay, I think we have it here. So the parameters can be explained as some inputs that you actually write when you are calling your function. So let me cite an example here. So when we were calling the print function, we pass on something like, let's say, 56, and then it prints 56. What this implies is that this function, which is called the print, when it was being defined, it was given the opportunity to take a particular variable. That means that when you are calling this function, you need to pass on a variable which the function will transform the variable to give you this output. So the variable that was defined when the function was being defined originally is what we call the argument. All right. It's what we call the parameters. Okay, it's what we call the parameters. But when you call it, we call it argument. So now we have def telling Python that you want to define a function. Then you bring the name of the function. And if your function is to take some parameters that you use to perform some calculations, you put it here. Exactly 2 items. So with that exactly 2, I divide some parameters, and then within the function, you like to perform some arithmetic operation which adds the 2 particular arguments that you will provide in the function. I think when we see an example, it will be much easier. We have this where we call the optional description of what the function does. So once you create a function, maybe somebody would like to pick your code, but the person doesn't know what the function means because maybe the name might not be too descriptive. Even though you have to make sure that the name correlates to the function is doing, you can still provide kind of a documentation, a brief documentation about your function, and it is optional. Then your body, where you give in some instructions, and then you have the return method where you return the result or an output. All right, so this is just the structure, and I think once we see an example, you'll be able to. All right, so when you want to call a function, you just write the name of the function and then you put it in parentheses. All right, so now let's try to let's try to write a small Python function. In this Python function, what we want to do with a particular text. So the text is, welcome to Confanochi Teaching Hospital. Please take a seat and wait to be called. This is what we want to print to the person. Okay. All right. So when you want to define function, as we saw over here, and even there is a syntax over here, we use the def keyword and then the function name. So here we don't need any argument, or we are not sorry, if we need any parameter, we can pass it within the parentheses. But in this case, we don't need any parameter in the code within our function, anything like that. So once we run this function, this function has been loaded. I mean, it has been committed to Python's memory. That okay, we have a function called the function. We just call greet clinic with the parentheses. Just as wasn't any parameter, so that's why it is empty. So amazingly, when I run this code, the Python is going to print these. Okay, so let's see it in action. Can you see, welcome to Confanochi Teaching Hospital. Please take a seat and call this code several times anywhere in your code after defining function. So let me just copy this, okay, and then come to the last page of the notebook. Okay, and then here I'm going to say greet clinic. So please, can you see the magic over here? So I did not define all these things. I just have a function which has all these parameters. So when I call it, even at the end of the notebook, you see that I'm still seeing a Confanochi, the welcome message. All right. So that is that. So this is the basic form of a function. The basic form of a function. Okay. So in this case, I don't have to define these things again. That when the particular criteria is being met, print instance. Okay. Make it kind of like a kind of something that a user can take. Something a program that can take. Please, someone's microphone is unmuted. Please kindly mute it. Okay. So we can make it kind of a program, and then in this program we take a user input. Once we have the user input, what we do is that we take it whether the person has visited the hospital, then we show the person that message. Okay. All right. So I was saying that in Python we have something that we call function, and one of the purpose of the function is to reuse your code without writing the entire thing. Okay. And how do you do that? So you do that by first defining a function, and in Python you begin with the def keyword, and then you provide a function name. So it could be any name, but the name should relate to what the function does, so that once you are calling, it will resonate. Okay. So once you have that, then you bring your parentheses, bracket, open bracket, close. Then once you're done, you define something, what the function should do. So in this case, this function, greet clinic, what we are trying to tell it to do is to print welcome to Confanochi Teaching Hospital. And also to print, please take a seat and wait to be called. So that is what we want the function to do. That's what we want to print to any patient at all. So once we are done defining the function and defining what it should do, the task that it should perform, then we are done. So we can close it by just running it. So the way we run code in Jupyter Notebook, your control plus enter. So now I have committed the function to Python. I've told him that this is a function and this is what the function is supposed to do. So now if I want to print this to a patient, I don't need to write them myself. All that I need to do is to call the function, which is the greet clinic, which is the exact thing that we defined over here. So when I call the greet clinic, you realize that it's prints welcome to Confanoche Teaching Hospital. Please take your seat. And I was demonstrating by saying that once the function is defined, you can move to the last page and still call the function. What was the name of the function? Greet something. Okay, greet clinic. Okay, once you run, you see that it's being printed here. So I did not type these ones manually. I just defined one function, and I'm calling that function anywhere to print out or to perform this particular action for me. Please, do you get it now? You get it?
Yes, I do. Yeah.
Okay. So this is just an example that if we don't have a function, we need to type them manually each time. But we can write a function and give it a work to do. And the work is to print all these things. So each time we call the function, it will just print them out. And here you can see that we have the items being printed out over here. Okay. All right. So parameters and arguments. So previously, the function that we created, we did not add any arguments. So when you define a parameter, so when you are defining a function, that is when you are writing the function. Anything you provide within the brackets is called a parameter. But when you are calling a function, anything that you provide within the bracket is called an argument. So you have to be able to differentiate between the two. When you are defining a function, anything you pass in between the brackets of the function that you are defining is called a parameter. But when you are calling the function, anything that you provide within the brackets is called an argument. So in this case, we are trying to write a function that greets a person, let's say a patient, and tells the patient that the doctor will see you shortly. We want to do this for every patient who comes and registers. So imagine we have our hospital is ultramodern, and so once you come, you need to type your details. So maybe the person types the details and everything. So once the person types the detail, all that we want to do is that we want to greet the person, good morning to the person, provided it's morning, hello. Though we can write a code that will look at the time and then greet the person based on the time. But today, for simplicity's sake, let's take the good morning. And then say that the doctor will see you shortly. Okay. All right. So in this case, here we have a parameter. So the parameter, it means that each time you call the function, you need to provide a parameter here. And it is that same parameter that you can see over here. So what we are trying to say, the definition of this function is that create a function, name it greet patient, and within the greet patient, take the name of the patient. And what you are supposed to do with the name is that print good morning, then you bring the name, which is this same name, and then print the doctor will see you shortly. So that is our function being defined. When we want to call this function, let me just delete all these things so that we have only one example. So when we want to call this function, let's say greet. What's the name of the patient? Amma Boateng. So the expected behavior is that Python is going to pick the Amma Boateng and then call this function. So you are calling this function. So the name Amma Boateng over here will be printed. So you will see that on the screen, good morning, Amma Boateng. The doctor will see you soon. Now let's run it and see. You see that it is doing justice. And when you see that, instead of typing print good morning name and then the other text, the doctor will see you shortly, we've just defined a function. And all that we need to do is to call the function on any name at all. Okay, so here is Amma Boateng, the ones that I deleted. So good morning, Kofi Mensah, the doctor will see you shortly, and so forth. Okay, So for clarity's sake, let me just use this print function here to just separate them out. Okay, so patient 1 days, patient 2 days, patient 3 days, and you know that for each of them, we did not define this, we just define it once, and we are calling it on them. So we can just create a simple program whereby we take an input. So we can say that name equals to input type a name. Okay, type your name. Okay. Then we pick that name. Okay, so we are just using the same. So greet patients, then name. Okay, so here simple name. We are taking the name of the person, and then we greet the person. Without the function, we are going to say name. Then we are now going to write this print good morning and everything all the time. But with the function that we need to say that greet name. Let's see that in real action. So it gives you the opportunity to type a name. So let's say Grace. Okay. When you run Grace, say that good morning, Grace. The doctor will see you shortly. Did you get it? All right. So I mean that's the beauty about functions. Yeah. So you define it, and then the rest you call it, and then it works for you. If you, when defining it, when you use an argument, when calling it, you have to provide an argument. Let's see when we try to call each of the function without an argument. So greet patient without an argument, we get an error. Okay. So the error says that greet patient missing one required positional argument name. So he's telling us that the function that we define requires a positional argument, which is the name. But when we were calling the function, we did not provide the name. Okay. All right. So, but when you put in numbers, it will tell you good morning 145 because that is the name that you provided. All right. So that is basically that is that. But however, we've talked about no parameter, one parameter. Python can take several parameters and even an infinite number of parameters. Okay, so now let's look at it. But however, we can't write a program that is an infinite number of parameters. Okay, so let's say here we want to print the details of the patient. So the patient has to provide the name, age, and then diagnosis. So patient summary. So we are going to print the patient's name, the patient's age, and after the diagnosis, what did we find? And then we want to print these hyphen 30 times. Okay, so let's see it in real action. So this is our function that we've defined. I mean, the only novel thing over here is this first line, because these ones we already know them. And so this first line is your dev function name and then the parameters that you want to take when you are calling the function. So here we have patient name. We are calling the function patient summary. So here the name corresponds to Ama Boateng, age 34, and then diagnosis malaria. And then you see that once we do that, it has printed it patient Ama Boateng, age 34, diagnosis malaria. And then when we call the second one, so you can call it on all the patients, and then you are going to get their records without you typing these things over and over again, because the function holds all these tasks. And then once you call it, it will perform it for you automatically. That's that. All right. So now let's add some more technicalities. All these ones we are just printing, but let's try to add more technicalities to it. So we want to check for eligibility. You know that previously we were trying to write a code that checks for eligibility, whether a person qualifies for an exam or a scholarship or something. So each and every without function, we have to run that code every time in order to. We have to type the code every time in order to check. But with the function, you define the criteria, and every person, you put the person's name into or his details into the function, and the function is able to tell you whether the person qualifies or not. So here, let's look at it. So our function would take 3 parameters, okay, positional parameters, and we'll get to know what the positional means. So So this is some printing. So print checking eligibility for name, the name of the person which corresponds to this. Okay. And then you see that if score greater than 50 and attendance greater than 70, print result eligible to sit the final exam. Else print result not eligible. Very simple. So in this case here we are calling our function check eligibility. And so we are providing all these parameters as arguments over here. So name Amma, the score is this, and the attendance is this. So and then we define for 3, but definitely let me just try with 1. Okay, so when you do that, you see that it has checked for the eligibility for us without really looking at it. So checking eligibility for Amma, result eligible to sit the final exam. So we said this in a lot of machines and everything. There are some of them when you type your details, it tells you that your details are right or not every time. Every time. So what it means is that every time you type your details go into a function which checks whether you are eligible to enter or not. Okay. So with this, you can use the input to take some information. Okay. So let's say just define some input functions. So let's say name equals to input. Okay, so we say type your full name. Okay, that is our first one, and then the second one is age, no score. Score, we have to convert it into an integer, and then we say input. Okay, then we say type your full, no, age doesn't have full age, so type your age here. All right, then you have the last one, which is your attendance. So the attendance is going to be that. So since that's a numeric value, we don't want to keep it as a string, because when you keep it as a string, we cannot check for the condition. And when you type anything which is not a string, it will give you an error because of the integer. So which is not a numeric value. It will give you an error because of the integer, because you are trying to convert everything into an integer, because ideally by default the input variable returns a string number of attendance. Okay, so once we are done, then we call the function check eligibility, check underscore eligibility, then we are passing the name, score, then attendance. Okay, so let's see. So there is something wrong in it. Okay, there is no equal to sign. Okay, so now once you're done, so let's say the name is Grace, and then instead of full name, so Grace Johnson. Okay, and then the maybe the ages, let's say 36. 36 is too much, 24. And then let's say wait. I think it should be score instead. Okay, so let me run it again. Okay. Let me just type something. Okay, let me run the function again. All right, so first the name will be Grace Johnson. Okay, and then the score is, let's say Grace had 89, and then for school she came only 23 out of the number of days that they are supposed to come to school. So checking for eligibility, not eligible. Why? Because one criteria is not met over here. Okay, though she had good grades. Okay, good score in maybe MSM or anything. All right, so basically that is how it was like. So function, define something. Okay, so positional and keyword argument. So you know that earlier all the functions that we are defining, they are called positional. The functions with parameters are called positional parameters, or when you're calling the function, positional arguments. And the reason why they are positional is that we have arranged them in order. Okay, so when you are calling a function, it means that these items should be placed as they are when you are defining the function. So that's what we mean by positional argument. So let's say we want a function that is going to record the sale, okay, and calculate the total. So product and then the quantity and then the price, okay. So we are taking three arguments, and these are the arrangements. So what you are doing is that take these arguments or pick these parameters, which is the quantity and the price, which the person will provide, and multiply the quantity by the price and store it to a value, a variable called total, and then print. This is just a formatting. So print the product, the quantity, the price, and the total. All right. So in this case, we are trying to call this function, and so we can see that the product has in its place the product, which is the rice. The quantity has in its place the quantity, which is the 10, and the price has in its place the price, which is the 5.0. So let me just comment this. When we run this, so you see that we have 5 total. This is what this particular function is, and then one put it in curly brackets, and that's what they've done over here. Okay, all right. So you have that. Okay, all right. So these are called positional arguments. Let's try to see when we try to change something. Okay, so instead of here being the rice, we are putting the rice in the second place with a comma. And let's run and see what will happen. The Python is giving us an error. Can't multiply sequence by non-integer type of float. You get it? It's because of this. Why? Because the position, Python works based on the position of these particular variables that you declared over here. Okay, so based on its position. So when you mix the position, actually it's going to take that. So in this case, Python is interpreting that the 10 is your product, and then the quantity is a rice, and then the price is a 5.50. Okay, but in this case, that shouldn't be the case. The rice should be in the product, then the quantity should be second, then the price. So that's one of the things that you have to take notice. So that's what we call the positional argument. So let me just try. Okay, all right. So once we change the arrangement or the positions, it works beautifully. Now with the key, when we talk of the keyword argument, in the keyword argument, what we do is that we define these values when we are calling our function. So here in the record sales, the price we define it. So price equals to 8.0, product equals to oil, and then the quantity equals to 5. So when you do it this way, it doesn't matter the order because you have already defined these parameters. Okay, they have their values attached to them when you were calling the function. So Python does not care where they are because their values have been defined. So in this case, when you run this, when you realize that they have not been arranged in the way we've defined them in the function, but they will still work best because here, ideally, product here should be the that though that wasn't the case, but it's still working. But for the positional ones, whereby we call the function without defining the the parameters or the arguments, we need to put them in position as they appear when we are defining our function. Okay, so please, we are done with that one. Any question?
Daniel,
Yes.
if you want to enter over there in Python, how do you do it?
Okay, so in this place, I copied, so I opened my word and then I copied the character and then I came to place it. So, I mean, but there is a way of, I think, think 5 minutes, but I just copied it from somewhere. Or I even sometimes use the internet, so I want the CD symbol. So once you get a CD symbol, you can just come and put it there, provided it's not in the keyboard. So you know that the dollars is on the keyboard, but the CD sign is not there. So you just copy it and come and put it there. It's just a string. So it's very good.
Yeah.
Okay, good. All right, so we are moving on. So we have something, a function called the return statement. All right, so you can see that in the previous functions that we were writing, all that we do is to tell Python to print something, print an output, print an outcome. However, what the function prints cannot be used further. And so that's why we have the return statement. So the return statement returns a value that can be used further. So maybe your function should calculate something that should be passed on onto another function. In this case, you cannot use print because print will just print the value. But you can use the return to return a particular value of one function, which will be an argument for another function. Okay, so let's see that in raw practice. So in this case, we want to convert Celsius to Fahrenheit with Celsius as the parameter. So we will take a temperature measured in Celsius and convert it to Fahrenheit. So we define our function with a name that suits the purpose, Celsius to Fahrenheit. And then this is the calculation. So to convert Celsius to Fahrenheit, Fahrenheit will be equal to Celsius times 9 over 5 plus 32. And then we say that return Fahrenheit. So ideally, we could have said that print Fahrenheit, which is going to print only the Fahrenheit without we getting access to the value. But the return Fahrenheit gives you the value Fahrenheit. That is the value that this particular expression will produce. Okay. All right. So let's see. So once you have the value, you can assign that value that your function will output to a variable. So in this case, we call it result. So result equals to Celsius to Fahrenheit, which is 38.8. Sorry. So it's just the argument. But the Fahrenheit, once you run this function, is going to calculate, convert this Celsius into the Fahrenheit equivalent value. And then because the return keyword will give you the Fahrenheit value, you can assign that value to your result so that now your result becomes the calculation. Okay, so once you do that, now you can print the temperature in Fahrenheit with your result. All right, so let me call this and then let's see. Okay, so once I run, you see that temperature in Fahrenheit, that is 38.8. When you convert it to Fahrenheit, it's going to give you 101.3. Now, what this implies is that ideally we could have said print something, okay, but now we don't want to print, we want to output the something else. So in this case, we are assigning that value that will return by the function to result. Okay, and once we have that result, we print it. So that becomes this 1013. So let's see something over here. So provided I do not have all these things here, and I call the function alone, nothing happens. Okay, but however, the function is running. Okay. Oh wait, let me just call. I did not call the function. So Celsius to Fahrenheit. And then let's say giving it some value, maybe 38.5. Okay, so now you see that it has returned the value over here, Fahrenheit. Okay, however, this value can be inherited. So it means that once you call this function, it gives you this value. So if it gives me that value, I'm not using printing. So I'm not using print. So it means that it's an actual value, it's an integer. You can run the type here to figure it out. Okay, once you run the type, it's going to tell you that it's an integer. Okay, sorry, a float. Yeah, decimal. So it's a float. So it's an actual value. So once you have that, you can just assign it to a variable. And that is basically what we did over here. So that this variable result will inherit the outcome, this Fahrenheit. So basically, we are trying to say that result is equals to Fahrenheit, where this Fahrenheit is actually the Fahrenheit that the function returns. So this code over here is equivalent to this, but you cannot access this directly unless you call the function so that it will give you this. That's why we call the function on the argument 38.5. Okay, so basically that's what it does. All right, so you can also actually convert. I mean, there's just some kind of formatting, so no big deal, the same thing. Okay, so basically that is how the return keyword works. So it returns a value and not just printing an output. Okay, let's see that in another example. So we want to compute the area print. Okay, we know that area equals to length times width or breadth. Okay, so in this case, we say that we define our function, and then what our function is to do is to print length times width. So here it will show the result, but it will return nothing. But here when you say return length times width, it will return the value of length times width. So this is just kind of an output, like just show us something. But this one is telling us that give us the result, give us the value. Okay, so now you see that with the first one, compute area print, okay, function, you see that we will get a value, definitely. Okay, but this value that we had over here cannot be used to do anything. Okay, like I mean, it cannot be used to perform further calculations or anything. But however, when we use the return, it can be able to use to perform other calculation. It can be used to add up to something. Okay, maybe when you get the area, you would like to use the area to calculate the height. For that one, you need to use the return keyword, not just printing something. Okay, all right. So I think there was a scenario over here. So here we assign a variable a to compute area print. Okay, print stored value area equals to. So now we realize that here it's returned none. What it means is that the reason why it's returned none is that this print value over here is nothing. The function does not return any value that you can assign a variable to. That's why it is giving none. But when you run this function on its own, it's just going to print this. But let's consider for the compute area return. You realize that when we assign the variable area to the compute area return, we are able to store it, and then when we print this particular area B, which is this, assigned to this, we are getting the 50. So if you want your function to return a value that you want, you can use return. If not, you can just use your print and then you move on. All right, so all right, okay. So basically you can also return multiple things. Okay, so summarize calls.
Daniel.
Yes.
Daniel.
Yes.
Please, can you explain
yeah,
what you just? Can you explain it again? What you just did?
Okay. So what I'm trying to say is that I think the code is a lot. So let me just. Okay. So this is what I'm trying to say. When you define a function and you say that okay, print length times width. Okay, this particular print over here will not return a value, which is the value of the length times the width. And what I mean by the value is that it cannot return a value that you can use to do something. Okay, so how do we confirm that? So we can confirm that by using this example. So we are assigning a variable area A to compute area print, which is we are calling this function, and the length we are saying is 5, and the width we are saying it is 3. So when we run this particular code, okay, sorry, so after defining this area, then what we do is that we are going to print stored value, and then we are going to print this particular area which is assigned to this. Now the reason why we are trying to do this is that when you call this function, apparently it's supposed to return to you the product of the length and then the width. Okay, so that is what you are supposed to get, but we are saying that that output is not a value that Python can use to perform other calculations, and we are proving it by this. So when you run this particular code, you see that here we have 15, which is the product, right? Which is the product. However, when you are trying to print stored value, which is the area, it gives you none. Why? Because this just give you an output. This particular function, it just prints something. It just prints something to your display as in the value, but it does not return any value that you can use. So hold that one, and then let's come to this. When we define a function and we use the return, it returns the value. Instead of just printing the value, it returns the value of the product. So in this case, we can assign that value that will be returned to a variable called area B. And when we want to print that area B, it's going to give us the value that will be returned when you run this compute area return function on these two arguments. 15. Please, you get it? And you can actually use it to perform a lot of calculations. So you can say area B, B plus 40, and it's going to give you 55. Okay, but this area B has been assigned to only this function, and the truth of the matter is that this function will return the product, and that is your value, and we've assigned it to a variable. So we can use that value that the function will return to do everything based on its data type. So because it's a number, that's how I'm doing calculations. Please, I hope you get it.
So I do. But Daniel, please, can you speak louder? I'm struggling to hear.
Oh, okay. All right. Please, are we all facing similar challenges? Oh, we are cool with that. Okay. Okay, Grace, is it okay now? Is it okay? Can you hear me now?
Yeah, it's better.
Okay. All right. So we are making progress. All right. So we can return multiple values. Yeah. So we just summarize scores, and then score. We know this particular function mean score returns the minimum value, and then average we just calculate the mean, this particular formula, and then we see that return minimum, maximum, average. Okay. We return minimum, maximum, average. So in this case, what you are going to do is that definitely the scores will take kind of a list. So once we take the list, minimum will be the minimum score, the maximum will be the maximum score, the average is going to be this calculation to calculate the mean. Then we return. Now you see that here the function is returning 3 particular values. Okay, so we can unpack it by assigning 3 individual variables to the output. Okay, just as we did when we were learning tuples. So we learned that for tuples, when you have a tuple, let's say A, comma B equals to a tuple, maybe something. Okay. R and B equals to that item. So the function is working similarly like that. So in this case, low will represent minimum, high will represent maximum, average will represent the average. And the reason why we are assigning it to this is because when you run this particular function on this list, it will return to you these three. There you go. Okay, so I mean, it's very beautiful. Okay, so you can, now that we've defined the function, we can try it on any other list and then A tuple and then everything. So results. So instead of here unpacking it here, we are assigning the result to we are assigning the values to one result, to one variable called result. And then here we are saying that summary tuple comma result. Okay, and then average equals that. So basically, when you have two or more values, when you let your you allow your function, or when your function returns two or more values, the function returns those values as a tuple. Okay, all right. So that's how you are able to unpack it. If not for that, you can't unpack it. All right. So I want to show that one simply before we move on. All right. So let's say I just need this function. Let me assign it to a value called result, and let me call it outcome. Outcome equals to this. Okay. And then let me print the type of the outcome. So you see that we have a tuple. Okay. So when you run your function and you are returning multiple values, Python put them together as tuple. And the reason is that it makes it a tuple so that it becomes immutable, because those are the results that you are supposed to get. If it is a list, it can be changed, but if it is a tuple, it cannot be changed. So let me just undo them and then let's make progress. Okay. Okay, I think this is just something similar. Okay. Okay, so basically that is how the function works, and that's how we define the function. All right, so let me just jump. I'll be jumping one or two, so, but I mean, they all build on the previous intuition. So if you understand the previous one, that's all. So Python can also, a function can have a default parameter. Okay, when you say a default parameter, that parameter is already defined. Okay, you don't I mean, when nothing is being provided, when your function, when you call your function and you don't provide any arguments, still that particular parameter will work. So it's default, but however you can override its value. So let's see it in action. So record weight. So we are recording the weight of the patient in kilograms. So we are taking actually 3 arguments. So in this case, the unit over here is kind of a default parameter, okay, because here we have already assigned the unit to a particular value. So when you call the function and you don't make mention of the unit, Python will not raise a concern, because the unit value has already been defined. Being that the unit value has not been defined, then you have to provide it. However, the unit value, once defined as a parameter or a default parameter, can also be overridden. Okay, let's see that one in action. Okay, so once we call, okay, all right, so when we call this, you see that here we provided only 2 arguments, patient name and then the weight. We did not provide the unit. But however, when you call the function, the unit has come, because the unit kg over here is a default parameter. All right, but we are saying that this parameter can be overridden when we assign a new value to the unit. Okay, so here we are saying that value is Jane. So let's run it and see. So now it changes from kilogram to Jane, because we have assigned a new particular value to the unit, overriding its default value, kilogram. So that has to do with default parameters. Okay, so you can use default for currencies and all that. All right, so one thing that you have to notice is that the default parameter must always come after the required parameter. So maybe some of the parameters the person has to type, so like the name of the person, the person's program, but maybe they are for the form is collected for all level 100 students. So we are expecting that no matter what you do, the default value should be level 100. Okay, so here we've defined that, and we defined it's active true. Okay, so all that you need to do is to provide this and that, and we are saying that the ones that the person will provide when he's calling the function should come first because of the positional nature of function, argument, and parameters. Okay, so this one, when you run it, you're going to have that. So name that. So that's I was trying to do some formatting. Okay, all right, but I mean that is how it works. So positional argument, like something is deleted. Okay, it's hidden instead. All right, so positional argument. So I think I was trying to do some. This one. Okay, so positional argument, that is student and then that. Okay, that's for positional argument. And please any question on that positional argument and the default default parameters. Please, are we good? Okay, good. Okay, so that's that. So when we are done, we come to the args and then KW args. Okay, all right. So args collect any number of positional argument into a tuple, and quarks, so we call it quarks. So quarks, that's the technical name. Collect any number of keyword arguments into a dictionary. Now let's see them in action. So when we want to provide a number of positional arguments without specifying where it will end, you know that earlier the positional argument that the person is to provide, I mean we give it a limit. So if it is 3, you have to provide 3. When you provide 4, Python will give you an error because the number of argument that you are providing does not tally with your parameters. But with the args, what happens is that Python is able to collect any number of positional arguments, okay, and then work on them based on how you have defined your function. And this is the syntax. So you bring your star and then the arg name, so the argument name. Okay, let's see that in reaction. So maybe you want to define or write a function that calculates the total sales. Okay, so here we are saying that sales with this particular star and then the sales like that. Okay, so once we have that, what you are going to do is that print received, sales, then print type sales. I mean, we want to just check for the type, and then return sum sales. So we are going to return the sum, so it means that we are going to compute the total. Okay, so let's see that one in action. So here we are using tuples. So we are providing these values over here, but we are saying that the sales, Python will return collection of tuples. Okay, so let's do that. So you see that it sums up all these values over here, but it's just only one argument that we have over here. So ideally we were supposed to just provide one argument, but because of this star, it makes it a flexible parameter, and as a result of that, you can append or add any number of items that you want. So we can see that from this particular second code. Okay, so when we run this code, you see that the values over here, they are more than here, but it will still take them and calculate it for you. So you can add as many as you want. So let's try something. Okay, so I think it's okay. All right. So when we run still, it's going to calculate for us beautifully. Likewise, when we reduce it, it's going to calculate it for us. It's because of this particular sign over here. We tell Python that it takes a flexible number of parameters. Okay. All right. So that's for that. So we can do for scores, and then maybe we want to calculate the average of every of the scores of maybe a number of people. Yeah, average scores. So what I need to do is to provide the scores. It doesn't matter whether the number of scores are 1,000. So these are some of the things that Python use when it's working on your data. So your data will have a full column, and then once you run your average or the mean function on it, is that it will calculate the mean for all the values on that table. So Python actually uses of these things. So the scores represent the data there, and then the star tells him that take as number as you can. Okay, or based on the number of argument that is being provided. So here we can just also add more to it. Okay, just type something, and then it's supposed to calculate it for you no matter the length. Okay, that's what we call flexible arguments, and this is how we specify them. Okay, so for quarks, what we do is that we just need this, and then the name of it is that it returns. Initially, we made mention that it collects any number of keyword into a dictionary. Okay, so let's see that in action. So a function that builds a patient's record from any labeled fields provided. Okay, so we are defining our function. Say create record, and then the fields. So meaning that for any field that the user will input, Python is able to take them. Doesn't matter the number. So let's see what it does over here. So we are just going to print out record contents fields, asking what the person types, and then type. We are just trying to find the type. It's going to give you a dictionary. So we can say that for key, value in fields.items. So if this particular field will give you a dictionary, then we can retrieve the key and the value of a dictionary, because initially, if you recall, we said that dictionary contains key and then a value. And then when you run fields.items, it gives you the key and the value of every dictionary. So we are unpacking it by assigning every key of that dictionary item to key and every value of that dictionary to value. So we are saying that for key, value in fields.items, print f, the key and then its value. Let's call this function. To call this function, we are going to add the key and then the values of the records that we want to create. So here we want a key and then its value, a key and its value, a key and its value. Okay, so let's print, and then similar thing over here. Let's print it and see. So once we print, you see that the record content now has a dictionary. Okay, so what you are inputting as argument over here is being converted into a dictionary, which is here. Okay, and now once you have the dictionary, you can get the key and then the value by looping through them. So here the key and then its value, key and its value for the first patient, and then the second patient, key and its value, key and its value, key and its value. And you can add as many as you want, maybe anything. Blood, so let me just use gluc for glucose. Okay, and its value is 45. Let me use press for pressure, and then let me assign its value to 30. Let me use BMI for BMI to give you, let's say, 24. Let me use what again? Let me end here. Okay. All right, so let me just so Initially we specified just this, but we've appended some to it. But Python does not care. It will just work on it for us. Okay, so it takes any number of um, variable keywords. Okay, so it takes any number of value keyword, assigning value to value, no, a key and then its value. Yeah, so it assigns a key and its value, a key, and so as long as you are able to provide the number, the key and then its value, Python can take as many as you can. So it can even be 1,000 records. It doesn't care about a particular person. So that is how it works. So in this case, you can use it to collect data, a lot of data, and append it, make it like a database where you convert every. It takes a number of arguments, and then it convert them into your dictionary where you can look through to get these values. Okay, so that's basically what the quacks also do. However, maybe you might like to. These are some of the foundations or the things that built things on which other functions are being built. Okay, so this is the core of Python, especially some of these things. All right, so I think that is that. So combining, you can put them together. All right, so let me talk about the variables and then the scope. All right, so local scope, and we also have global scope. So when you talk of local scope, when you create a function and you define a variable within the function, okay, that variable, we call it a local scope. What it means is that you cannot access this variable outside the function. So I've created this function and I've created a variable called discount, and then I ran the function, and then I came to assign, I came to call this particular discount variable. Python will give me an error. It will tell me that it doesn't know about that particular variable, because that variable is a local variable. Local because it is being defined within a function. So that is what the local scope variable means. Okay. And then when we talk of global scope, it's a global scope variable. It's a variable which is being defined outside your function. So exchange rate is defined outside your function, but however, it can be used in your function. Okay. And after it's being used in your function, you can still access the same thing outside your function. So a local scope is being defined within the function. A global scope is being defined outside a function. So that's basically the difference. The other calculations are something that we know already, so I can't be going through. Okay, you can also convert a local variable to a global variable by using the global keyword before that particular that variable. So in this case, total sales over here is a global variable. Okay, so in this case, we are saying that we are declaring this particular total sales variable that we are creating over here a global variable. Okay, all right. So why? Because we intend to modify this particular global variable. So without this, Python is going, when you create a variable here, Python is going to accept it as a local variable, which will not allow you to use it outside your function. Okay, so the rest are calculations which you already know. So we talk about the docstrings. So the docstrings are kind of a text that is put in 3 quotation marks to give a brief description of your function. So over here we have that. So compute the body mass index of a person. Because when you provide your weight and then your height, it will compute the BMI by saying that BMI equals to weight over height times weight over height times height exponent 2. Okay, then it's returned around a 1 decimal place of the BMI. Okay, all right. So once you run this, and then the doc is going to give you what the function actually does and how it works. mean. So that's what we call the docstring, and it's actually what you provide in the parentheses. Okay, so I think this will be the last one, and then okay, we'll be done for this. But I will introduce the Matplotlib. So please bear with me. All right. So the reason why I'm not going through, because some of these calculations is some easy things that we've done already. So you know that when we were defining functions earlier, we used def, so we need to always define that function. But however, Python has something that we call anonymous one-line function, which is called a lambda function. So when you want to define a lambda function, you need your lambda parameters, which is kind of variables, and then expression, what you want to do with a particular variable. So let's see one. So if we want to find the square of any value, we write this function, def square x, return x double doubles and star will give you, so it's like x exponent 2. Okay, this means exponent. All right, so once you write this, it's going to work perfectly for you. Let's see that. So is that when you provide 5, it's going to give you 25. When you provide 100, it's going to give you that any number at all. When you provide 0, 0, when you provide 0.6, it's going to give you that anything. It's going to give you the square of it. All right. So we had 5. So that is, I mean, in a generic manner, that's how we have to define our function. But with lambda, that is not how we do it. So with lambda, what we do is that looking at the syntax, lambda is parameters than expression. So we say that square lambda equals to lambda. What's the parameter x? What do we want to do with the x? We want to square it. So you bring your colon. So kind of lambda, what's the parameter or the variable x? What do you want to do with x? So the colon means that we are defining the x as x exponent 2. So once you do this also, it's going to give you the same answer. Okay. The same thing, the same behavior, anytime. So that's how you can also write. So the lambda is another way of writing a function. However, we don't use it to write cumbersome functions. So a function that will contain a lot of expressions, we just go by the generic. But maybe you need a one-line function to do something simple. Then you have to just use the lambda without defining a function. All right, so we can also do that. So a function that adds 2 numbers. So in this case, we are defining our lambda function. So we say lambda. We want 2 parameters because we want to add 2 numbers. So x, y. What do you want to do with the 2 parameters? Add them. Okay, so initially, the parameters that you provide within your generic function, they are what you will define here when you write a lambda. Okay, so instead of saying def, square, and this, no, we don't need any name. So we want, instead of that, we use lambda. So the lambda over here is an equivalent form of def. And then this x and y are the parameters that you will provide within your function. And then below, the code that you write is what you will write after the colon. Okay, so very simple and easy to understand. Once you have the notebook, you can go through. Okay. All right. So we have the sorted function. Okay, maybe we want to sort. So let's see this in real action. So we have a list of tuples. Okay, a list of tuples, and then we want to sort by age. Okay, in ascending order. So we say that sorted patient. So the patient becomes this. Okay, and then key equals to lambda, that is the variable p, which is it's inheriting this, and then we say that p print the first index. Okay, the value at index position 1. So once you do that, and then once we are done, we loop through them to get the age. So let's see that in action. So what happens is that the entire tuple has been sorted in accordance to the age in ascending order from 28 to 34, and so on and so forth. Okay, so basically that is what the lambda does. Okay, I think this is just a similar example. All right, so the filter and then the map are all examples of functions that you can use on lambda. Okay. All right, so the filter actually takes the function and then I travel, so it keeps only items where the functions returns true. So we want to keep only the high glucose readings above 126. So we have the glucose readings as a list, and then we say that high glucose equals to a list. So this list will convert everything within. It will convert everything within the list within here into a list. So we say that filter lambda j, that's the expression or the parameter. Sorry, the parameter, and then we are defining the parameter should be greater than 126. Which data should we look at? We are looking at this, the glucose reading. So in this case, this function is going to look through and pull out all the values which are greater than 126. Okay, so when you print high glucose, it's going to return all glucose readings that are greater than 126 as a list because of this. Okay, because we are outputting everything into a list. So this can be equivalent to when we use the square brackets. It's going to give you similar thing. Oh wait, so I think this one is unable to convert it to a list. However, the function does. Okay, but basically it's converting to a list. Right, so you have that. All right, so basically that is how it works. And though it's not too common to be used anything normal data analysis, I mean having a pen and it is also good. Okay, so we have a nested function, which is you can define a function within a function, and I think it has to do with one function that we'll be finding another function where the values or the output will be utilized. So, and all these things we know already. So, okay, and we have something we call the recursive function, where a function calls itself. Though seldomly will you use this one, but however, I brought it so that by going through the notebook, you can also appreciate some of these things. Okay, so the recursive can be used as a factorial calculator, where when you whatever value that you provide as an argument to the factorial, it is just going to multiply. Those are the did math a bit, factorial. So it takes and multiplies, then -1, then it multiplies like that. So 5 times 4 times that, so the last value, which is 1. Okay, so basically that's that.
Daniel. Daniel.
Yeah. Great.
Daniel.
Yes, Grace. Yes, can you hear me?
I don't understand what you are doing.
You don't understand? Oh, wow. Which part? So that I can. So basically, what I'm trying to say is that the recursive part of the function, suddenly that you use it in data analysis, unless maybe you are a hardcore programmer that you use Python to create a lot of software. Okay, but I actually intentionally brought it so that you can also look at it and have a fair knowledge that there is something like that. Though there will be times that you are designing something, you are designing a program that you like to use a particular function or a particular you want the function to behave in a particular way. So with that, maybe it can come to your mind, okay, I remember about recursive function or recursion of functions that call themselves. Okay, so that can really help you. But there is no, it's not a big deal when you don't know the details of it. All right, please, is that the only part, or there are other parts that you don't understand?
It's okay.
Yeah. So basically, that's what I'm saying. So um, it's not everything that is kind of tailored to the goal. Okay, so I mean these are not only what the functions can do, and there are a lot of things. Okay, you can write a lot of complex functions, but you have to have a fair knowledge of what it is, what it can do, and I think that's what we've built. Okay, how to define a function, how to provide parameters, what the parameters do. Okay, so basically, if in data analysis you are going to do anything, it's going to revolve around that end. Okay, but when it comes to, and let's say the sorted, okay, but I mean, this one, even in data analysis, it will be explained more into details. But I'm just giving you an overview of what the function does, and we've talked about the core part. Okay, it's not that I'm skipping. You know that for the lambda, you have to know it, what it does, and then I've explained, and then all the key ones I've explained. But when it comes to nested function, seldomly we'll use a nested function in data analysis, unless maybe you are writing a hardcore program. But I brought it so that as you go through the notebook, you can see that, okay, there's something called a nested function. And I can explain everything, but because of time, okay, that's why I'm just, and all these particular expression, we know them. All that we need to know is about defining the function, which we know. And defining these functions that you've defined are functions within a function, a bigger function. Okay, so once you call this particular function, when you call it, it actually takes all these arguments, and once you run it, all these sub functions will be called within the function. Is how you are getting it. So in this case, analyze patients. All that we did was to provide the name, glucose, and BP, which we've done over here. All these sub functions over here are things that are helping you to achieve a particular goal. So in this case, let me just run it. So you see that it's no big deal. It's the same function, but you are within the function. You want something. You've created functions to perform some specific actions. Okay, to perform some specific actions. Yeah. So great. It's not a big deal. Okay. I mean, it's not that I'm skipping some. It's just not too relevant for our goal. Whether you are not going to learn Python for software engineering. Okay. And even know about the argument, positional argument, and how to define an argument and everything. Because most of the things that we will do are functions that has been written for us already. And so you only need a function when, let's say, you want to put a number of other functions together. Okay. So, and I was saying that once you create a function and then you create another function below it, it's just like creating a function and calling print. So you're just calling two functions. And the basics is what I've told you, which is relevant to what we are doing. Please, do you get it?
Yes, I do.
Okay, that's great. So we have some useful built-in functions like the round, which converts values to decimal places, takes two positional arguments, the value, and then the number of decimal places that you want it to be. So you just provide, and then it comes. All right, then we have the absolute. So the absolute returns the absolute value of any value. So when you have negative 3.5 and you run the absolute function on it, it will strip off the negative and return to you a positive value. Okay, so here I have a number of examples. So 3.5 is negative 0.3, negative 3.5, but when you run the absolute on it, it gives you that. And then we also have the power, which returns the exponentiation. It takes two parameters or two arguments, the value and then its power. So 1.2 here it can be read 1.2 comma 5. So 1.2 exponent 5. Okay, all right. So let's run it and see. So you have the 1.2 exponent 5 is going to give you 1.7623. And then its instance, it checks the type. Okay, so let's say you want to find out whether a value is of a particular type. Okay, so maybe you can say that its instance, then the value, what value is that, and then the type. So it checks the value against the type to see whether the value correlates to a type. If it is true, it is going to give you true. If it is false, it's going to give you false. So here we have if not is instance data comma list. So here what we are trying to do is like maybe you want to figure out is the data that will be provided a list. If not a list, return error. Expected a list. Okay. However, if it is a list, then it can perform something. So let's see that one in real action. So it's not if not is instance data comma list, it's going to return error expected a list. So let's see that save average. Here you provided a list, so it's going to give you the outcome. Here you did not provide a list. Okay, and so Python will say that error expected a list. Okay, and the last is instance is that if not all is instance comma s comma integer float for x in data, return error. All items must be numeric. What it means is that James, okay, can you mute yourself? So what it means is that all the items should be numeric values. So this one, it is a list. However, some of the items is not a numeric value, and this particular function checks. And we know about the all, we know about the not. So it's that if not all the items within the
instance.
Yeah, so that's what we are using the is instance for. Okay, please you get it now. All right, so that's the function of the is instance. And then we have the input, which we've seen it a lot. And then we have open for reading files. So if you want to open a file from your desktop, okay, you can use open to open the file. I mean, we will not be doing file open, but I'm just telling you that there's something like that to open files. Okay. All right. So I think we are done with the functions. So in summary, functions are code blocks that are reusable. That one you have to know. So maybe if you are performing in your analysis, there is something that you have to do it over and over a particular, over different data sets, or over different columns, you can write a function that you will use to call. That is basically how we apply it in data analysis. Maybe you have to calculate or filter something. So you're using the code to filter, but you want to do this for different or multiple columns. So you can write a function, and then the column that you want to work on will become your argument, so that once you pass your column on it, Python will be able to filter it. So basically that is what it does. And the most important thing I want you to catch is how to define a function, how to provide a parameter, how to provide parameters and argument, and positional argument, and then also keyword argument. All right, so basically that's all. And then the return statement, very crucial, because I also spent time on that to explain to you. So basically that's all. We are done with the function. Any question? Data sets, they are able to, any of the data structures, you can use it to model, okay, visualize something. And once it's that, it is very easy when the thing is small, because once you have a table that has a column of 100, 200, and so on and so forth, it's hard for you to understand what the code is actually doing. So that's why for the curriculum that I developed, I have brought the data visualizations, not to just appeal to your appetite, but to help you to build the intuition. Okay. All right. So data visualization is important for all these particular reasons, which I know that these ones we can read it ourselves. All right, so let's look at this particular data structure. I think we've come across something like this before. We call this one a list of dictionaries, whereby each of the dictionaries contain information about a particular ID, a patient ID or a particular patient. So we have a number of them here. Okay, and we are seeing that this particular structure of data represents a tabular data like this. Okay, so when you take this tabular data, you have patient ID, name, age, and that. It's the same thing that we are mimicking over here, isn't it? So you have your patient IDs on this particular row, patient ID. You have your name. So the name over here is actually the column name, and that age, and for glucose and that. So basically, you see that the data that we have in this particular table is just an exact representation of the data structures that we've learned. Okay, so while we have a list of dictionaries, each dictionary corresponds to each patient. Okay, so now when we try to print each, so it's that we have a dictionary, and when you look at it critically, you see that it's just contained information about one patient, and so on and so forth. Okay, and this information mimics the information in this particular tabular form. All right, so when you have this particular rows, where, because now we know that they are dictionaries, if they are dictionaries, we can extract the rows. So here we are saying that put the outcome into a list. Row age. So we are extracting age for row in patient data set. So for row in patient data set, we are picking or collecting all those in the age column. So now you come to the age, we are collecting all these values, okay, for the age. And then we say glucose level, we collect all those from the glucose level using row glucose, because the raw glucose, the key glucose, is to search for the key glucose and get all these. And these things, we learn them using the for loop. All right, and then the names, we can do that. So now let's see that in real action. So by this code, we've been able to extract the name, ages, and then the glucose level of the patient into a list. So you see that we have a list containing only ages of the patients, and that's, and also that. All right, so this is just to let you know that the data structures that we've learned represent a table in Excel. Okay, so I think my Excel is ready, so let me show it on the screen. So let me show the Excel on the screen. Okay, so now let's look at this table over here. Okay, so let's consider this Excel table. You see that it has patient ID. It is the same way that we have stored. So for the dictionary that you are seeing, each dictionary contains this information. Each dictionary contains this information. And then the code that we wrote was that extract only the information in the age section, and another one, extract only the information here. So each row represents the dictionary. So we are saying that, okay, if each row is a dictionary, then we want the values of the age, the values in the age column. So we say that row, which represent the dictionary, get the age value. So we are using a for loop. So if it's a for loop, then it's going to iterate. So here, the first row, the age, it will get it. Then the second row, the age, it will get it. Third row, age. Fourth row. So that is exactly what we are seeing over here. Okay, that is exactly what we are seeing over here. It has extracted the names. So that is how it works. All right, and then we also have parallel list, whereby we store the values not in a list of dictionaries, but only just lists. So here we have the values. This is just a breakpoint, so we can just make it one list, but just that it looks a bit longer, so we truncate it here, and it's the same. It works perfectly. All right, so we have that. So a list can also be your data. So look at it. So here, instead of we having like a dictionary kind of a list which looks like this, now we have a list of values where each represents something. So here the month can be the month column, and then the revenue can be the revenue, where the values in the revenue are the values in the table, and then the cost for the cost. Okay, for the cost over here. So basically, what I'm trying to communicate across is that the data that we see, okay, in the tables, they are built from some of these things. So if they are built from some of these things, and these things represent the columns of the data, the values of the columns of the data, then we can use these ones to learn how to plot. And once we master the plotting, we can use actual data to plot. Okay, and then tuples can be used as threshold, which we will see when we begin. All right, so we can also use the dictionary to group items. So maybe the company has, let's say, branches in different regions in Ghana. So we've grouped all the sales by branch. So Accra branch, this was the sales, this was the sales, this was the sales, this was the sales. And so by using a key and value, we can extract only the regions and also the values and use it to make some good plots. Okay. All right. So when you do that, you see that we have collected the branch names as list, and then the branch totals as also a list by extracting these values from our dictionary that we've created over here. Okay, so we use the list to also remove duplicates and to find only unique values, as we've learned earlier. All right, so it doesn't need any big explanation. So for Matplotlib is used for plotting. So we will just do one plotting, and then I will end today's session. One thing I will let you know is that I will put a link on the page for you to download this, and I'm hoping that Sunday we all sit by our computer so that we do with our hands. So it's going to be a real time something. So I'm going to it is going to be a real time something. I think for the visualization, once you do it and you see it for yourself, it also helps you to understand what the code is doing. All right, but provided you don't have time, that's also okay. So I'm not going to explain any of these, but I'm just going to run one for you to see. Okay, and then run a plot. Okay, I think this is a good plot instead. Okay. All right, so you see that we have a very beautiful plot over here. So plot of month against revenue. So by this plot, we know that in the month of February, the revenue reduces. From then, it has been increasing. All right, so basically that's what we will be doing. So that's the introduction. I have given the overview about how the basic data structures that we've learned mimic the data that we have in tables. All right, so with that said, we bring today's session to a close. I'll see you on Sunday. Kindly do well and go through the notebook that will be shared. It's very important. And if you have any question to let me know about it. Okay. And also let me